Okay, so before I get started, I did write some code. If you're interested in it, it's located in my GitHub account. You can look in there. There are a few states in there. There's a couple of execution modules which cover specifically what we're going to talk about today. And I will, in the interest of full disclosure, I'm not a security researcher. I'm not really a terrific security expert. I've been in the business for 25 years. I understand what it takes to harden a server and why you want to close ports and so forth. But one of the reasons that they asked me to do this presentation is because I wrote a blog post when the Ghost vulnerability came out about how you could use Salt to kind of check all your machines to make sure that you weren't vulnerable. And that's kind of how I ended up here. So I did have a I did have an extensive presentation planned covering server hardening, package vulnerabilities, configuration drift, how to use IP tables, and then we were going to do a hands-on demo. And we actually did get the demo prepped, but we've been having such issues with the network here in the hotel that I didn't want to frustrate you guys. So all the code's available, and we're going to talk about some of that. But then yesterday at 2 o'clock, something kind of interesting happened, and that was this. And of course, for all of us who know what this is all about, we know that this isn't really that big a deal. But if you look in the corner, this showed up in the Washington Post. And for a number of us, what's going to happen is we're going to come back from the conference and our boss is going to walk in the door and say, "Did you fix that?" And you got to be able to say yes, or you have to be able to explain to him or her exactly what's going on and why it's not that big a deal. So last night, I ditched a bunch of my presentation and sat down and wrote some execution modules for looking at this very thing. And that's what we're going to talk about today. So now, since it's after lunch, and I know everybody's really kind of getting a little sleepy, here's something to wake you up.
Here it comes.
Cylons are hacking our network. They're attempting to access our gateway.
Now it's a race.
First firewall penetrated. Second firewall's been breached. Frack, they're fast. Third firewall down. They're through the fourth firewall. One left till they've accessed our mainframe. We have a solution for the fleet's position.
Break the network.
Hang tight. Check in, Galen, check in.
Network is broken. Computers restored to local control.
Tell the Vipers to get back to work. We're getting awful lucky today. Prepare to jump.
Okay, everybody awake? All right. Okay, so what's Freak all about? Freak deals with export ciphers. Does anybody know, just raise your hand, humor me for a second. Does anybody not know what this is about? Okay, good, because preaching to the choir isn't all that much fun. Back in the 90s, the US government put controls on the types of encryption that we could export from this country. In particular, they mandated that anything we exported used a 512-bit or smaller key. Back in the 90s, that wasn't really a big deal, but now we have a heck of a lot of computing power at our disposal. For $10 in Amazon, you can spin up a couple hundred machines and perform a factoring attack. And so export ciphers are not something that anybody needs to be using anymore. They really need to be turned off, and there are a lot of servers out there that are misconfigured to allow export ciphers. So in particular, there's a number of browsers out there that also will try to negotiate export ciphers. In particular, Safari on iOS, almost all the Android browsers, Safari on macOS, and even IE11 in the current Windows Tech Preview will all negotiate a 512-bit or smaller export cipher. And there are a whole bunch of very high-profile websites that are vulnerable to this. So how would we mitigate something like this? So ideally, you'd say, okay, I have a bunch of web servers running. I don't really want to go look at all their configuration files separately. Is there some way that I can take a look and see if any of them will negotiate this export cipher? So for each running server, let's check and see if there's a running process that is bound to port 443. Let's enumerate all the ciphers that are available. Let's try to negotiate a connection for each cipher that's available, and then ultimately we would update the types of ciphers that are accepted if it is vulnerable. Okay, so first let me just show you how that works. Let me get some of this out of the way. All right, so first, there we go. All right, so this is an execution module. Can everybody read that? I can read it from here, but this is an execution module, and all it does is on the machine that it's run on, run a netstat. Actually, we use Salt's netstat, built-in netstat execution module, which calls out to netstat it's available. And check to see if there's anything that's bound to 443. And if so, let's append that to a list, and then we'll return everything that's, we'll return all those addresses that are bound to 443. So that's the first thing that we need to know. And the second thing we want to do is in this module. So we're going to ask OpenSSL about all the ciphers that it knows about. And so this is just a really simple parser that opens a pipe to OpenSSL, grabs all the ciphers, parses them out, and then anything that starts with EXP is an export cipher. So those are the ones that we need to check. After that, we want to check an individual server for the cipher. So we're going to contact the web server at the past host name, forcing the past cipher. And we're going to also use OpenSSL for that. Call out to S-client, pick the cipher, do the connect, and then there's a whole bunch of stuff that can come back from that. If you've ever, I'm sure most of us have run OpenSSL on the command line. You get a whole bunch of junk back. So we'll parse that out and get the stuff that we're interested in. In particular, there's one line in there that just says, this is the cipher that I picked. Okay. And then finally, down here, well, not finally. There we go. We have a function called server check, which checks the machines that this function is running on, which would be a minion for any processes listening on port 443. And if there is one, go through the export ciphers, do the connections, basically put together everything that we did just now. And then it'll return us a dictionary with everything that we need to know. Now, originally, this was part of the demo, and I was going to have you guys actually go in and take a look at all that. But I will just do it here. This is running in a container on my machine, just in case the network was totally unavailable. So make this a little bigger. Okay. So I'm just going to check this one minion, WS1. We're going to run cipher check, server check on it. And here's what we get back. Okay. So for that minion, there is one cipher that's present, and it's there because I configured it that way. And then at the end, we say success equals false. So that way we know that we should fail out if this particular server is vulnerable. So after that, well, how would you fix that? Okay, so this is the default file for the Nginx server that's running in that container. And right here is the evil line. So though we negotiate SSL version 3 and all the different TLSs for SSL ciphers, we're specifically saying, okay, it's okay to use this one. And that's how I tested the execution module. So if you find servers that are vulnerable, in order to fix that, you need to change this configuration file. So for anybody who's used to Salt, this isn't really a big deal. I have a state file in here called update nginx, and we're just going to file.manage that thing right down. So this is the file that's been fixed, and you can see that I've removed that particular cipher from the allowed ciphers list. So let's send that down. Salt ws1 state.sls update nginx. Moment of truth. Yes. Okay. So here are the changes. You can look at that and say, oh, yeah, that worked. All right. Now let's restart that, which may not work. I may have to go start it by hand because this is running in an LXC container, and sometimes things don't work quite right. Okay. And now let's run check again. Yeah. Yeah, it's still running. There we go. Okay. So that's kind of the most important part of vulnerability mitigation, right? Is you can push your changes out, but you really need to check and see if they worked. So, and that's what we did here. We can tell from the results that if you ran this state, if you did it in a state file or you did it in some of the orchestration, engine, at the end it says success true, and you can be sure that none of those ciphers are present on that web server. So, any questions about that before I move to the next topic? Anybody taking a nap in the back? If you are, I'm terribly jealous. Oh, there's Mike. He's grinning. All right. Okay. All right, so let's talk about package vulnerabilities. Obviously, that's the first place where vulnerabilities kind of appear, right? You've got a package installed on your machine. There's a CVE release for it, and the distributions update the packages, and so you want to go grab the updated ones. Well, so that's kind of the obvious first thing to do, is just do a salt package.upgrade refresh equal true to make sure that you get updated from all the distributions package databases. So what do you do about running processes at that point? Well, we'll talk about Ghost in a second. Debian and Ubuntu actually have a program called check restart, which will go through and look and see, after you upgrade a package, are there any running programs that still have open files to libraries that were updated in the process? Because that's kind of the neat thing about Unix and Linux is, even if you remove a file that's in use, the file doesn't actually go away until all of the open file handles are closed. So that means that you can have running processes that are still running code that's vulnerable, and you probably better check for that. So check restart is in the Debian goodies package. CentOS and RHEL 5 have a program called needs updating, which does the same kind of thing. And then RHEL 6 and CentOS 6 have yum plugin PS, which right now appears horribly broken. So I wanted to demonstrate that, but I just could not get it to work. So does anybody happen to be more familiar with that than I am? I'm just curious to know why it was broken. So anyway, I did not look further into that, but those are good things to run on your machine. And just like what we did with parsing through all the OpenSSL stuff, it's not that hard to write a module to go in and run those particular programs on each one of your minions, return you some data, and then you can get an overview of of your entire infrastructure about what might still need to be restarted, because you don't always want to reboot the whole machine, right? You'd really just prefer to restart the packages or the daemons or whatever that are using the files that got updated in the process. All right. Okay. Now, let's see. Let me talk about that in a different way. Configuration drift. So does anybody run a periodic high state on all your machines? How's that working out for you? Works great? Doesn't work great? Okay. Configuration drift is kind of something you have to watch. In some of our infrastructures, it's not a big deal because you're really controlling everything. But in some other infrastructures where you have a number of people accessing machines and doing different things with them, you kind of want to make sure that all the files that you're managing with Salt get handled the same way. So just some examples, you probably want to make sure etc host is managed by Salt. Resolve.conf, ld.so.conf, all those things probably better be, canonical copies ought to be on your Salt master, and you can push them out. And so to do that, you can schedule high states. You can either do it in an etc Salt minion, or you can do it in your minion pillar. And it's really simple. Schedule high state, and the function is state.highstate. You can do it every 60 minutes or every 15 minutes or whatever feels comfortable for you. If you came from the Puppet world, or maybe you're still in the Puppet world, this is kind of old hat to you because this is kind of how Puppet does things. But pretty valuable, something that I've seen used to great effect in a number of different infrastructures. Okay. The other way that you can do this is through state.top. Maybe you don't want to run an actual high state, but maybe you've got a set of things that you just want to check all the time. And so we have state.top in Salt now, where your top file doesn't have to be named top. You can call it something else, and then you just call this a state.top with the name of the top file. So if you have all your configuration maybe is in your high state, but you've got a few things you just want to check on every so often, maybe every half an hour or whatever, that would be a good place to do that. All right. So that was the live lab. I want to show you the ghost thing. So all right. So I wrote this back in January. The ghost vulnerability actually had to do, well, it was vulnerability in libc. So, lots of programs use libc. And to test for it, this is actually why I was really interested in this particular example, because it's a C program. A lot of us don't work in compiled languages anymore. We do most everything in scripting languages. I cut my teeth on C many years ago. I used to use it for just about everything. I'm a little bit rusty nowadays. But if somebody hands you a C file, what are you going to do with it? Well, you could actually use it to mitigate this vulnerability. So the original code's here on openwall.com. You can look that up if you want. And again, this is all in my GitHub repository. So this program just basically checks for the buffer overflow. We're going to save that. We saved that to a file called ghost.c, and then we compiled it with GCC. It's really easy to compile. It's not like some of the larger C programs where you need to pull in a bunch of libraries. So when you run it, you're either going to get not vulnerable with an exit code of 0, or vulnerable with an exit code of 1. So if you want to deploy this across 1,000 machines, how are you going to do that? Well, I kind of use the degenerate case in this example. assuming that all your machines are running the same distribution as your salt master, which I know is not true for many people. So we save ghost.c to a directory on your master. We compile it as I described above. Then you drop the executable in your sort of salt directory or wherever your file roots is pointed, and then you can use this SLS to deploy that out to all your machines. And one of the important things is right here, this mode, 0644 actually probably, yeah. That probably should be 0755. So we fire that off on all the minions with this, and just like we did with the previous example, Salt will treat the result of command.run as a failure if the return code is non-zero, and then all the vulnerable minions would show that the test failed. So, and just as kind of as a point of discussion, most of us run 64-bit machines. You can actually compile Ghost for a 32-bit machine on a 64-bit machine, and that's just not something I got around to. But that's what this error message means. So if you try to run the executable on a machine that's a 32-bit machine, you're going to get this weird error back. No such file or directory. Whoops, did not mean to do that. And it kind of looks like a bug in Salt. I mean, we've had those before, but it's really not. The no such file or directory part is the loader is looking for the 64-bit shared libraries, and they're not there on a 32-bit machine. So that's why you get the file not found. So the way to handle that is if you happen to have a 32-bit machine around, you can compile it, and that's what I discussed in this article. And then we bring that file back to the master and then push it back out to all the 32-bit machines. And let's see, yeah, with this. So the SLS changes just a little bit. File.managed, and we're checking for the architecture of i386. And then we use Ghost32 instead. All right. So finally, there's this little tidbit. Which, let me run that over here and see what comes up. Oh, not what I expected. Invalid option. Okay. That's interesting. Okay. Okay, Mike, you're not the only one for a demo fail today. So what this is supposed to tell you is the name of all the running processes. This is like check restart. It's just a little bit more raw. It's supposed to tell you the name of all the running processes that need to be restarted. Yeah, that was weird. Oh, you know what? I bet it was a cut and paste failure when I put this on medium. That's bitten me before. So let's see if we can make that run. Oh, wrong machine. Yeah, there we go. Okay, this is in a different environment. Let me see what I've got here. Yeah, this is actually my home network, plus a bunch of machines that I maintain out on the internet. And this is an earlier version of 2015.2, which is why that error is popping up. That error actually has been fixed in the current tree. So let's see who's around. Oh yeah, we have a few that are up and running. Okay, salt star. Ooh, lots of interesting stuff. Okay, let's see what this looks like. Okay, so the first thing we do, we push that executable out. Yeah, it looks like my SLS is actually testing this backwards. So if you'll forgive me that. On this machine, DB01, it looks like it's not vulnerable. The ret code is 1, though. Yeah, so these all say not vulnerable, but actually I flipped the sense of the test. So now on this machine, which one is this? Oh. This is Mac OS 10, so it would blow up. And this machine actually fails because that is an ARM server in the cloud. It's not an x86 machine. So this executable makes no sense to that machine. And the same thing with this one. And this is another Mac. And this is my machine that's sitting here on the desk. And, oh, we actually got something back that was correct. So W01 is a machine in DigitalOcean, and it was one of the ones that I originally ran this test with, and it's actually reporting the right stuff. So, and then the rest of these are not. None of these machines are online. So not a great test, but just an example for how you could possibly do that if you needed to. All right. Okay, like I mentioned before, these files are available in my GitHub repository. If you're interested in looking at any of these, all the Go stuff is here. Originally, we were going to spin up a bunch of containers in the cloud, so that's what these other SLSs are for if you would like to kind of experiment with firing up machines with LXC in the cloud. So those are in there too. And then in the modules directory are these two that we worked with, looking for port processes that bound to port 443 or CipherCheck, which goes through and checks all the OpenSSL ciphers. And then in files are just the two Nginx configuration files. The first one, if you want to try to pre-configure some of your web servers to make sure that the test actually is going to report something valid, that would be this one. And then this configuration file does not have that inside of it. Okay. All right. So I intentionally left about 10 minutes for questions. So anybody have questions? Anybody have interesting stories they want to share, or stuff that you've done to mitigate issues in your own environment that you think might be interesting for the rest of us? Ooh, okay. I'm sorry, what? Oh, yeah, that was for Heartbleed. Yes, it was. Yeah. Okay. Yeah, that is actually kind of interesting. I'm glad you noticed that. to deal with these, this is actually another misconfiguration of SSL protocols. You want to make sure that v2 is not available anymore, and ideally v3 is not available anymore. So this actually just runs through your Apache configuration file and pulls out the valid stanzas in your configuration file. And if these are present, then it gets rid of them. And here's the same thing for Nginx. Looking for this particular protocol line. And then for postfix, if you happen to be running postfix as your mail server, I use postfix. I don't use any of the other mail servers. There isn't any particular reason for that. Also, if you happen to have Chromium installed, it checked for that too. Or Iceweasel, if you're running one of the Debian derivatives that uses Iceweasel. So yeah, that's what that was all about. Any questions about that? I can put that in a repo too if you're interested in it, but Poodle and Heartbleed are kind of old news now. Yeah, go ahead. It's up to you. I don't really have a preference. I don't run large infrastructures. I work at Salt. We don't have a 5,000 node data center. So it's not really a big deal for me to just run it on all the minions. The stuff that I work with is like 10 or 20 nodes. So it's kind of up to you. And kind of balance performance. And maybe your master's underpowered and it's better to run it, schedule that on the minions. Mm-hmm. Yeah, that's a great point. That is something you probably want to think about. Any other questions? All right, so we're ending a little early. Again, I'm CR Oldham. I work for SaltStack. I'm on the core team. If you have questions, come and find me. You can find me on GitHub or Twitter, or just send me an email. I hope this was useful. Oh, yeah, sure. Oh, I must have closed that. There. All right, thanks a lot.